a logic of logic, computation and modal logic through possibility, quantification. Here's the outline. I'll first talk about world, its metaphysic and its logic, and the relation between logic and metaphysic of anything. And then I'll talk about logic and the corresponding metaphysic, and logic, the metaphysic of logic and the logic of logic. With that, I will bring out what a computation theory of something is, and especially of logic to present my logic of logic. And lastly, I will show how all this can be performed using only first order predicate logic. World and its metaphysic, how things are, facts, and the relations, how things are, how different objects instantiating different properties, and when certain objects are instantiating properties, its relation to other objects instantiating certain properties, and how it is like they across possible worlds. And of course, when we only talk about the actual world, that's the history of the world, and of course we're also interested in what could have been, the alternatives, and to see it through the modality of things, things in the world, what's essentially a certain way and what's otherwise. And that's one way we understand the world, and the facts that they are, facts are the way that they are without us knowing them. But in virtue of describing them truly, truths and the relations operating on truth, I think that's what logic does. And of course, logic. What one way to understand logic, inferences ought to have been truth preserving, and so when we reason about the world, mediated by language with a certain logicality, when we make inferences using logic, that's the truth preservingness of the operation. That's how it's different from how facts relate to one another. So a computation theory of the world, well, we've talked about the world, its modality, when the actual fact about how a certain thing is and what it could have been, going beyond a modal logic about truth and its mode, whether it's a necessary truth or a contingent truth. I try to separate to draw out the given a realist metaphysic, how the two relates, the representation and the represented, the relation, modality. And one way to understand modality is using possibility, or necessity. That's in all possibility. Well, there's no, well, to put it in another way, if something is necessarily the way that it is, then there's no possibility which is otherwise. So that's one way to understand modality, especially necessity. Accessibility, that's the advancement in modal logic that Saul Aaron Kripke brought forward. Well, a relative possibility, as he puts it, or a possibility from something, because something is possible from a certain thing being a certain way, but not that thing being another way. And the computation theory that state machine, for example, how this can incorporate accessibility, and that's what I'm going to do here. So logic. well, to contrast world, it's metaphysic and it's logic. So even with logic, there's also it's metaphysic and it's a logical fact. For example, explosion. That's not a well. That's a case of explosion. It's not It doesn't belong to logic. I think that's one way I would put it. So a logic of logic that on which there are, that's not the right one. I think that's an operation with truths and especially inferences that will result in, for example, any argument with whatever conclusion there is, it's a valid argument. I think that's one way to conclude that that's not a logical system that we ought to have accepted. And so a computation theory of logic, very simply, with, well, a state machine, to describe it in terms of state machine and computation, in terms of function of, let's say, X and Y in that order, and output Z, something like that, using this notation to describe logic. So here's the computation part, state. One thing that we can use accessibility in computation is to describe a state using accessibility. So objects instantiate properties, and at a certain stage, it relate to other objects in a certain way. And if we can describe their relation using accessibility, that given that if we're describing the world, and then their relation would be a metaphysical one, and stage, most probably it's a temporal stage. It depends on, it will raise issue with whether time is linear, but given some assumption and a metaphysical accessibility, how it will be used to describe properties, even if accessibility is usually at least a two-place. Well, if we use a two-place predicate, then it could also be a relation with itself. These are still work in progress, but relation using the accessibility, a relation to describe relation among objects at a certain stage, that's a state, and the set of accessibilities, given the objects and the set of accessibilities among the object, that's the state of a machine that is, well, at a certain time, the stage. If the transition is across time, then it's the temporal stage. Computation, to use function to describe that a state transition given input. I think that's something very obvious. What the how it works. So given if a state described using accessibility, set of accessibilities, given that the formalism would have worked out, then state transition modifies is through modifying accessibilities and applying a function is a rule that takes certain thing into a certain thing, and will given certain input. So there are a few, there are the variables and what are being modified, and in so a function would be a set of states, ordered pairs of states, and in relation to inputs, which are variables, of course. And computation from function to system, a system has a goal state. Well, if we are designing a system, then we well, there's the designed goal state where the state that it will reach, probably given a certain time. But of course, there's the problem of the range of inputs, because if the system is receiving input that's not what it's designed to receive, then maybe it won't reach the goal state. And given this view of, or the system view of anything, we have an order. When it's a perfect order, then perfect order, its measure is 1. And when it's 0, I think that's chaos. And chaos is when there's no longer the system. The decrease in order, and correspondingly, the decrease in order corresponding to the increase in disorder, up to a point that there's no more system, and the measure of rate of decrease in order, when the input, when there's no continual input that's within range, entropy. I think that's and of course the I'm building up towards how these notions can be used in this formalism. So so system, set of functions, and the system is embedded in an environment, and the formal object, that context, is can be used to understand situation, the situationality, the environment that an autonomous system is in. And given that there are more than one system, there are times when there are dependent system interaction, especially when the input is from the output of another system. It could be a system that's higher or at the same level, and together they constitute a higher system, which, ignoring other things, would itself be the context that the system is in. Of course, an interaction is also within an environment, and that interaction, input and output, and the higher level system has a measure of of equilibrium and how it sustains the ideal would be both be at the goal state, and as environment evolves, they improve, or at least well, I guess that would be one way to understand even biological systems in relation to nature, to the environment, that nature is in terms of input, output, and their initial condition, and which is also in terms of a deterministic, well, is a state machine that, given a variable input that could be dependent on the environment, or even independent of anything. So set of systems, context. And all these can be described using first order practical logic, I hope. Quantifier, generality, and the problem is with domain of quantification and restricted domain. If I were to describe of an object, its essential property, that P, I can use A as a name for the object, for the individual, and if to instantiate a property is to belong to a certain class, and to use set to describe a class, then that object belongs to that class in all possible worlds, and worlds are also objects as well. So if we're given a certain conception of domain of quantification, of domain at all, and that's one way to describe something's modality, especially describe its essence, using only first order practical logic, and even with some likely indiscernibility of identicals, then you just quantify over sets. So two things that's identical if one thing belongs to a certain set, and then the other also belongs to that set. That's well, given the the virtue of first order practical logic, if that's doable, then I think one implication for this project would be to have a logic of logic that has a decision procedure that's sound and complete. So, and of course, for given a quantification description of possibility, to describe possibility using quantifiers, to do what modal logic is supposed to do, there's also axioms that's to be formulated, especially with accessibility relation. And then, for example, if it's symmetric, then it's expressible very simply by quantifying over everything the accessibility relation that's symmetric. So that's how I envision a logic of logic. So the summary of my talk, I start with distinguishing metaphysics and logic. The study of I would think that the metaphysics of the metaphysics as a discipline and logic as a discipline, there's still presupposition about how they relate to one another. So metaphysics, fact, logic, representation of fact, and operating on the representation. If it's sentences, especially if it's in a formal language with a well-defined, what a well-formed formula is, then the operation on the truth would be much simpler if the representation, the vehicle representation is a formal language. But with regard to natural languages, I think that's of course another thing. So logic, it's metaphysics and it's logic. The logic of logic to bring in other computation theory, and so that it has its place in the discussion of logic. As I think that it does, given the use of modal logic, especially accessibility relation, to describe what a state is in state machine. And having said all that, because all these is expressible using first order practical logic, then I look forward to any complication and further work all these imply. Thank you very much.